Let's take a look at some other types of problem solving. So we've got rate of work and mixture problems. So example number 1 says that it takes machine A 6 hours to complete a job, and the same job would take machine B 8 hours to complete. So how long will it take to complete the job if both machines are working simultaneously? So we want to solve algebraically. Before we get into solving algebraically, just to consider how we develop the equation and what makes sense for labeling, what I want you to think about is this. So if I put together a little chart here just to help you to organize the thinking. So if we take a look at time, of course in hours, since both of them are taking hours to complete, if 1 hour passes, the amount of the job that machine A would have completed would be 1/6 of the job, because it takes them 6 hours working at a constant rate. Similarly, machine B will have completed 1/8 of the job. The total of the job that will be completed at this point is whatever 1/6 plus 1/8 is. And of course, that's not one whole job yet, so we know that it takes more than 1 hour. Continuing on, if 2 hours have gone by, then machine A will have completed 2/6, or 1/3 of the job. Machine B will have completed 2/8, or 1/4 of the job. So if I write out those simplified forms, 1/3 and 1/4, then the total amount of the job that's been completed is 1/3 plus 1/4. At this point, we can see we've still not completed the whole job just yet. If 3 hours have gone by, machine A has completed 3/6 of the job, or is also 1/2 of the job. Machine B has completed 3/8, so we are definitely getting closer, because in total, the amount of the job that's been completed is 1/2 plus 3/8, but it's still not yet one whole job. So what we can see here is, yeah, we can reason our way through it, except at some point it may not be a whole number of hours, in which case we end up with having to estimate as opposed to having an exact value. Because let's take a look. If 4 hours have gone by, then machine A has taken 4/6 of the job. They've completed 4/6 of the job, or 2/3, and machine B has completed 4/8, or 1/2 of the job. And at this point, when we add 2/3 plus 1/2, we know that this is already greater than 1. So together, it does not take 4 hours to complete the job. So it's somewhere between 3 and 4 hours. So we want to find out an equation, determine an equation to help us to solve for that exact amount of time. So let's take a look then. If time instead was given by x, number of hours, then machine A will be completing x over 6 of the job. Machine B will be completing x over 8 of the job. So together, they're completing x over 6 plus x over 8. And so that then will help us to put together our equation. So every time you go through these types of questions, you don't have to draw up this whole table, but it may be helpful for you if you're unsure of how to put that together. Is just start thinking about how much time it's going to take, how much each machine will complete in that given amount of time. So our equation then is going to be, switch a color, so the amount of the job completed by machine A plus the amount completed by machine B, and together it should equal one whole job completed. Of course, if we're going to change that to 2 jobs completed, then instead of the 1, it would equal to 2. So take a moment at this point. This should be an easier equation for you guys to solve. So hit pause and work through that solution. So taking a look then, we multiplied everything through by 24 because that would be the least common multiple of our denominators 6 and 8, allow us to get rid of that denominator. So that cleaning that up, it makes it 4x plus 3x is equal to 24. Cleaning up the left side then, 7x is equal to 24. X is equal to 24 sevenths. And remember, x, back over here, we defined x then as the amount of time in hours. So x is then 3 3/7 of an hour. That's how much time, and that it would take for both machines to complete the job if they're working together, and that makes sense. We knew that it was somewhere between 3 and 4 hours. If we change that into a decimal by dividing 24 by 7, we end up with 3.42857 approximately. Hours. And so if we wanted to convert that into hours and minutes, be careful. Common mistake that we see is people think that this is when they look at the decimal, they think this is 3 hours and 43 minutes approximately. Obviously their tune changes when they see it perhaps as, instead, if it was 3.85, it can't be 3 hours and 85 minutes. That just wouldn't make sense. So remembering that time is not in base 10 as decimals are. So this is actually saying it's approximately 43 hundredths of an hour, or just less than half of an hour. So if we wanted to figure it out, what we can do is we can do a couple of things. We can take 3/7 and say, well, how many minutes over 60 is that? We can solve that as a proportion. Or we can also take that decimal 42857, and multiply that by 60, and either way we end up with the number of minutes being approximately then 25.7 minutes, or about 26 minutes. So that makes sense, just under half an hour. And so a statement would then say it would take about, whoops, started mixing my words there, take about 3 hours 26 minutes for both machines to complete the job. Okay, excellent. Let's take a look then at example 2. So example 2 is a mixture problem, and we've got 5 fluid ounces of a 2% alcohol solution mixed in with 11 fluid ounces of a 66% alcohol solution. We want to find the concentration of the new mixture. So sometimes for something like this, a mixture problem, it might be helpful for you to build a table. So we've got solution A and solution B, and we've also got the total solution together. We've got the concentration, and we've got the amount, in this case in fluid ounces, and then we also have the actual mixture piece of it. So the concentration for solution A is 2% or 0.02, and we've got 5 fluid ounces. So what are we talking about as a mixture? We've got 2% of 5 ounces. For solution B, that is 66% alcohol solution, and we have 11 fluid ounces. So the mixture then would be 66 hundredths times 11, and when we look at the total, well, we're trying to figure out the concentration of our mixture, so that might be our X. The total amount we can see is, if we add 5 ounces and 11 fluid ounces, we've got then 16 fluid ounces, and then our mixture is just the combination of those together then. So the mixture is then 16 times X. So there's our equation then, is, I'll write that on the side here, so 0.02 or 2 hundredths times 5. So 5 ounces of the 2% concentration plus 11 ounces of the 66% combination totals 16 ounces of the X concentration. So let's clean that up and we can solve for x, which is the concentration of our combination there. So we've got then 1/10 plus 7 26 is equal to 16x, or 7.36 is equal to 16x. Divide both by 16, and x, which is our concentration, is then 0.46, which means that that is 46%. So concentration of the mixture is 46%. And that makes sense. If you think about it, we've got a very, very strong mixture, strong solution, solution B, which is 66%, and we've got a lot more of it, 11 fluid ounces as opposed to just 5 fluid ounces. And so that's going to really, really impact that 5 fluid ounces of only the 2% solution. So that makes sense then that our concentration is 46%. Okay, so there are additional practice questions for you. Please let me know if you have any questions.